Okay, today we are solving AS paper 2, May, June 2019, and the variant is 22. Okay, this variant we're doing today. And we are planning to solve this in the reverse order. Like we will start from the last question because we have recently completed this topic. Now, state what is meant by field lines, line of force of an electric field. Field lines show field lines show direction of force on test positive charge in electric field. Because direction of electric field in junior classes, you are told that electric field is from positive to negative. But the actual definition is that if you want to know the direction of electric field, just put a positive charge over there. Whatever direction of force is experienced by that test positive charge that you have placed is the direction of electric field. It will always be away from the positive and towards the negative. An electric field has two different regions, X and Y. The electric field strength is less than in X is less than that in Y. Describe a difference. Lines will be closer in region X than in Y. Now, a particle P has a mass 1.5 U. This is mass of particle. And a charge -1 elementary charge, where E is the elementary charge. The particle P and alpha particle are in same uniform electric field. Calculate the ratio of magnitude of acceleration of P divided by magnitude of acceleration of alpha. Remember, this is the data that you need. Particle P, alpha. P has a mass of P equals to 0.15 U. Mass of alpha. Remember, alpha particle is made up of 2 protons and 2 neutrons. Each proton and neutron has mass 1 U. So this will be 4 U. Now, force charge equals to -1. Charge equals to +2. So force will be, because they are in the same electric field, force will be -1 and +2. And we are talking about the magnitude of the force. So negative sign will not make any issue. And acceleration equals to force over mass. Acceleration of alpha equals to force over mass. So that means acceleration of P will be 1 over 0.15 U divided by 2 divided by 4 U. So it will become 1 over 0.15 U multiplied by 4 U divided by 2. U can cancel with U, 2 into 2. So we have 2 over 0.15 or 200 over 15 or 40/3 or 13.3. You can confirm with the calculator.
Yes.
Particle P has a hadron composed of two quarks. One of them is down quark. By considering the charge, determine the possible type. Sometimes the vitals of a quark are also called its flavor of other quarks. Other quark. Explain your working. A hadron is composed of only two quarks. One of them is a down quark. Particle P. As we know that the particle P has a mass 0.15 and charge -1. So it is composed of a down, which is -1/3, plus there is a question mark particle that is missing. So what should be the charge of this particle that will make it -1 over here? So that means -1 equals to -1/3 plus x. So x equals to -1/3. Sorry, -1 plus 1/3, which is -2/3. So which particle has a charge of -2/3?
Up.
No, anti-up. Anti-up quark is -2/3e. So it should be an anti-up quark. Now, let's come to the electricity. Kirchhoff's second law. Total EMF developed in a closed loop is equal to total potential difference in the same loop. Now, a battery of electromotive force 5.6 volt and internal resistance R is connected to two external resistors. This reading on voltmeter is 4.8. Calculate the combined resistance of the two resistors connected in parallel. This should be easy. Two resistors are there, so resistance will be 18 multiplied by 90 divided by 18 plus 90. One, 10, 12. So 15 ohms. The current in the battery. Okay, now if we know the potential difference, the voltmeter is showing 4.8. It means the total potential difference across these two is 4.8. And if we know the total potential difference and their total resistance, we can find out the current. I equals to 4.8 divided by 15. So it will be 0.32 amperes. You can check it with the calculator if it is right. Show that the internal resistance is 2.5 ohm. if I know the current that is going, because the current that is coming over here, for example, if it is 0.32, it is 0.32 here as well. So the current that goes through the battery is also 0.32 ampere. So the formula is EMF minus IR equals to V. So R equals to E minus V over I. So 5.6 minus 4.8 divided by 0.32. 0.8 divided by 0.32. So let's make number of decimals equal. We can cancel decimals. 10 over 4, 2.5 ounce. Hence, no. Confusion?
Sir, in part 1, 2, why are we not using 5.6? Why are we using 4.8?
Oh, because listen, 5.6 is actually produced by the battery, but to the external circuit, it is only delivering 4.8. So if we are looking for the current that is passing through 90 ohm and 18 ohm, we should know what is the potential difference across these resistors. 5.6 is not making its way to 90 and 18 ohm resistors. 5.6 is the total EMF generated by any chemical reaction inside the battery. Some of that energy is lost within the structure of the battery to deliver while the current is going to the terminals of the battery. Now, what is the potential difference across 90 ohm and 18 ohm? Is it 5.6 or 4.8? Do you understand why don't we use 5.6? Are you still confused? So the resistors are actually getting 4.8 volt, not 5.6, because out of 5.6, some are lost within the battery. We call them lost volts. Okay. The volts are lost within the battery, and this is the resistance of the internal resistance. Now, determine the ratio of power dissipated by the internal resistance R divided by total power produced by the battery. Now, power equals to VI. So for internal resistance, for internal resistance, I equals to 0.32 ampere, R equals to 2.5 ohm. Can I find V, loss volts? That will be 0.32 multiplied by 2.5. So 0.32 and 0.32, 0.64 plus 0.1, so 0.80 volts. Now, power equals to 0.80 into 0.32. Now, for battery, total power will be total EMF 5.6 multiplied by 0.32. So when we are finding this ratio, it will be simple, 0.80 into 0.32 divided by 5.60 into 0.32 So 3 by 3 2 becomes irrelevant. It is
1/7.
8/56, 1/7, 0.142143. Can you confirm it with the calculator?
Yes, sir, 0.14.
142 something.
1428.
Okay, so good. Now the battery is now connected to a battery of EMF 7.2 volt and Turner resistance 3.5 ampere. Sorry, the resistance 3.5 ohm, 7.2 volt. Determine the current in the circuit. Now, the thing is that both of the potential differences are against one another. So total potential difference is let's say there is a current I. So potential difference across this one will be I into 0.25, 0.255. In this case, it will be 3.5 I. So total EMF will be 7.2 minus 5.6, which is equal to total potential difference, which is 0.25 I plus 3.5 I, 3.75 I equals to 1.6. I equals to 1.6 divided by 3.75. Which is 0.43. Okay. So this is how we are supposed to solve electricity questions. Now, for a progressive water wave, state what is meant by displacement. Distance of a particle from its equilibrium position at any instant. Amplitude is maximum distance of a particle from its equilibrium position. Now, two coherent waves X and Y meet at point and superpose. The phase difference between the wave at the point is 180 degrees. The wave X has an amplitude of 1.2 and intensity I. Wave Y has an amplitude 6 centimeter. Calculate in terms of I the resultant intensity of the meeting point. Number one, if at the midpoint they are out of phase by 180 degrees, so obviously they're undergoing some destructive interference. Excuse me. Resultant amplitude should be equal to 3.6 minus 1.2 equals to 2.4 centimeter. Now, intensity and amplitude, they are proportional. So if intensity is I, amplitude is 1.2 square. If it is 2.4 square, intensity is X. They are supposed to cross multiply because they're directly proportional. So X will be 4I. I can see because amplitude has been doubled. And if two things are directly proportional, one with the square of the other, if you double the quantity, then the other quantity changes by the factor of 4. So intensity at that point will be 4 times more. Monochromatic light is incident on a diffraction grating. Describe the diffraction of the wave as they pass through a grating. Monochromatic light is incident on a diffraction grating. Describe the diffraction of the light wave as they pass through diffraction. When light or any wave goes through a small gap, it spreads. This phenomenon is called diffraction. But in grating, there are multiple gaps. So multiple diffracted waves interfere and produce maxima and minimum. Okay, but multiple maximums and multiple minimums are produced. Now, parallel beam of light consists of two wavelengths, 540 nanometer and 630 nanometer. The light is incident only on a diffraction grating. The third order diffraction maximum are produced for each of the two wavelengths. No higher order are produced for either wavelength. Determine the smallest possible line spacing for the grating. D sin theta equals to n lambda. So if there will be same D with sin theta, bigger wavelength will be producing bigger angles. So bigger wavelength will get to 90-degree thing before the other. So bigger wavelength is 630. So use lambda equals to 630. nanometer, or 6.30 into 10 to the power minus 7. Or for some people, it is not easy to shift, so you can also write it 613 to 10 to the power minus 9. They're all good. Now, theta in this case will be 90. N equals to 3. Let's find out D. So D will be equal to 3 into 6.3 into 10 to the power minus 7 divided by sin 90. So D is 1.89 into 10 to the power minus 6 meters. To confirm your answer, you can find out D with the other wavelength as well. But that will not make sense because that will always be smaller than this one. Sorry, that will be bigger than this one. So this will be the smaller answer. The beam of light in this is replaced by the beam of blue light incident on the same diffraction gradient. State and explain whether the third order diffraction maximum is produced. Blue light has smaller wavelength. So smaller angles between orders, hence more orders produced. So yes, third order is produced. Okay, we will continue from the same point tomorrow.
Okay.
Okay.
Okay.